All right, I'm going to show you how to use a bore gauge set to measure a bore. Um, and at the same time, I'm going to compare that one with the wireless set that we have here. Of course, you can do both ways, depends what you have. So what I have here is a bore gauge set. Basically, what you need to do is just you put that analog gauge on top of the bore gauge kit, and what I have here in the background, there's an iPad and there's a wireless dial that you can connect and do the whole process a little bit more automated for more accurate and also faster part measurement. If you have many parts to the measurement, you want to do like documentation and measurement and recording everything. What I have here also is a micrometer, because the bore gauge itself doesn't measure anything directly. There's no absolute number. It just gives you this number, relative number, is a comparison gauge basically. It compares this number versus a reference that you calibrated to, right? So it shows you how much change you have. I need a reference. Either you can have a setting ring and take that setting ring and calibrate your bore gauge with that setting ring and zero it, and then you see how much deviation you have. Or if you don't have setting ring, use your micrometer and set that micrometer to calibration value that you want. For our case, for the purpose of example, I have a part here. That's the part specs. It says the ID should be 1.960 with the tolerance of 1,000. It's a pre-tight tolerance. The upper limit, lower limit, and everything is showing up here. The question is if this part is accepted or rejected based on this specs. The gauge they have, each increment is 5 10,000. So the tolerance is very tight again. So what you need to do is just put the micrometer and set it to that number. I already have done that, 1.960. I set it and locked it. Put it on the clamp. Make sure you don't tie too tight the clamp, otherwise you can damage the micrometer. And now I'm gonna just put this caliper, the bore gauge here, and just within the micrometer rock it back and forth, right? And you see the number goes to maximum number and it comes back. Then you have to zero it. This is the tricky part. This is the hard part actually. So you have to try many times to make sure that max it's zeroed. Not yet. Not yet. Let's see. Not yet. How about now? So that's the part that's part of the job, which of course is not that accurate. It's all based on the visual work. So you have to look at that dial, make sure it's zeroed. Of course, with our wireless and with that iPad system, everything's automated. There is no way that you can just make error. The human error will be gone. So you see almost the maximum is zero, just a little more. I think now we're good. So now the whole thing is calibrated. So let's see. No, it's good. So when it goes to zero, that shows that 1.960. So now you can move this one away, bring your part based on the specs, and see if putting this tolerance or not. Of course, when you put it here, you see the maximum. It's going a little bit further than zero. That's good. Well, the question is, what is that number? You want to write it down. You have to look at that increment. You have to decrease, like one increment means 5 10,000 minus that number, right? And then it's going to be 1.9595 probably, or 1.959. So, and write it down just for documentation purpose. Go to another point, again, rock it back and forth and look at the maximum. Again, everything is visual, based on visual, and the user, the operator, should make sure like it's in front of the face and everything is reading accurate, and just write down that number. So as you can see, the whole process is not the best process, the most accurate way of doing it. But let's see how we can do the whole process with our wireless dial gauge. So what I'm gonna do, I'm gonna take this part out, and since this one we have a different version, this is a metric one, so you have to use that adapter that we have, and make sure it can sit here. So once you do that, you have to turn on the Bluetooth, go to our MultiGage app, which is an iPad app, and pair with that gauge. So I'm gonna go into pairing mode, and it's gonna just select the gauge. It's gonna pair. Once you pair, the value is showing there, right? Let me just install that one on the top of the gauge that we have. So there's an adapter that makes it right size for putting that metric dial to this inch bore gauge measurement. So if you have different type of bore gauge, you already either metric or inch, you should be able to use our system by so now you can install this dial right away and make sure it's tight enough. Okay, and once it's tight, okay, so now you see when I push this one, right, the number is changing. So now I need to do calibration. The way the calibration works here is, again, doing almost the same process. I'm gonna bring this one here. Make sure you see the full screen here. So there's a maximum reading that always it's captured here out of my reading, because this wireless gauge is transmitting data continuously. And let's see, when I put here within the micrometer back and forth, now I don't need to go through that analog resetting or zeroing many times to make sure I'm reading it right. So the maximum reading here is showing here, right? So let's do it again, make sure I'm reading it right. Put the gauge here and rock it back and forth. You just need the maximum, right? And the software is taking the maximum for you, which is 0.0. Let me write down here, so you know now that measurement that we have, 1.960, right? That was the size of the micrometer. It shows as the max, which is 0.01905. So there's something here in calculator mode that you can go and zero it. One way is just I can put an equation in that that calculator page as this maximum 0.01905 minus the reading of the gauge at each time, which is called S1. If you do that, let's see what I get. 0.01905, right? Minus the reading of the gauge, which is called S1, or you can tap on the name of the gauge automatically as an enter. So if you add this one as a gauge, new gauge, right? And now if I come here, let's see what happens. So basically, you can see how much deviation you have from that reading, right? So it's already calibrated now, basically, right? So you see the number goes to 0 and goes back. Of course, it's jumping because it's real time. What I can do, I can go to setting of that new gauge I created. So we'll always keep the minimum reading, right? And what happens if you go do that, and then always gonna keep the minimum reading for you, which means that if I go to this measurement, rock it back and forth, keeps the minimum reading. So it's calibrated, of course. So if I just take this one and put in my part right away, make sure clear it again before each time that you do measurement, and rock it back and forth, it tells you how much deviation you have. It's 0, so it's very accurate. It's 0. So you can add more digit here, and if you want to see more accuracy, more digit out of your reading also, like for example here, right? 0 it, and you see it's pretty accurate actually. So the whole process, you see, much more accurate than the analog gauge. And so you see, if the different angle, I have 2/10,000ths of inch deviation, which is totally within my tolerance. Well, that's one option. How about if I want to just read the exact number of ID and document it? So what you can do, remember, we created this equation, so you can have the same equation plus the size that you had, right? Plus 1.960, the same equation. So I'm gonna keep this one. I'm gonna create a new gauge actually because I wanna have both of them. That's good. So 1.960 plus the difference between this maximum calibrated number, right? 0.01905 minus S1. Make sure the equation is right. Yes, everything looks good. Here we go. I have two gauges now. This gauge shows how much deviation you have from the zero. This gauge shows exact number of the ID at each moment. Again, this one is a real-time value, it's jumping up and down. What I need a minimum reading. Perfect. Go to setting of the gauge and just put the minimum reading and save it. So always gonna hold the minimum reading. Another beauty of this whole system is right now I can enter my tolerance. What was the tolerance? You guys remember? 1,000. So the upper limit now is, let's turn on the tolerance mode. Upper limit 1.961. The lower is 1.959. Save everything. So now what I have, it shows a color background color that shows if the part is within your tolerance or not. That's beautiful, right? Okay, well, let's see. Before each measurement, don't forget, clear your previous measurement within my tolerance. Perfect. That's awesome. Automatically captures the minimum. Save it. That's good. Let's do another measurement. Clear again. Go to another angle. Perfect. You can save it. And of course, those numbers that I save, I can go back here and look at them, right? See, there's a table. Let's do another one. Clear again, always. And captured, saved. One more time. So you see the whole process now, it's very automated, very accurate. There is no human error. Only what you need to do is just put the dial gauge here, the bore gauge, and just rock it back and forth. The software, the system automatically captures everything. Tap, save. Then you can also look at the plot, of course. Look at this. Perfect. Everything is within my tolerance, right? Then you can come here, save the whole thing for future reference. Everything's saved. You can go to main page anytime you want and look at those readings that you just captured. There are three gauges, of course, all are recorded and saved. One of them is deviation from the zero, the other one is absolute number. Of course, you can look at that and see the numbers of my measurement. Well, this part looks like a perfect part. Thanks for loading the right part for me. Everything's good. If you have any question, let us know and make any comment that you have. Thanks for watching.